Hello students. What I'm showing you now, what you can see on your screen is basically a simulation video of the photoelectric experiment. So simulation video basically means a computer model of a real-time scenario. So that is what you're seeing. So as I share this video, as I speak in this video, please follow the cursor and try to follow. So what you see here, there are few things which you'll have to notice. There are some controllable parameters and there are some observable parameters. So here we have intensity. I'll be controlling this intensity. I'll be changing this, and I'll be looking at what effects that it creates in the circuit. And you can also see the wavelength of light which I'm using here. It is presently set at 400 nanometers, which is basically in the blue spectrum of visible light. Now, apart from that, here you can see the metal I'm using as the cathode. This is the cathode. So the left side one is the cathode. So it is of sodium. And I guess you're all aware that the work function of sodium is 2.3 electron volts. And when you convert that 2.3 electron volts into threshold wavelength, the threshold wavelength turns out to be 540 nanometers approximately. So the wavelength which I have used here is lesser than that. So you can definitely observe photoelectric effect. Now, apart from that, there are two more quantities which you'll have to look at. So this one here is the voltage of the battery. I can make it positive or negative either by moving the switch to the right or to the left. So presently it is at 0, and similarly here you can observe the photo current that is established in the circuit. Okay, now let's see what happens when I increase the intensity. So as I increase the intensity, light, you can observe that the light is now striking the cathode. And if I increase the intensity further, you can see more and more bright light goes and strikes the cathode. And as a result, more and more electrons are emitted from the cathode. Now, as you can see, because of that, there is some current which is established in the circuit. It is presently 0.057. The units are unknown. You just assume that it is some value. So 0.057 is the current in the circuit. Now, you can see that as I increase the intensity, the current further increases, and if I decrease, it further decreases. And the reason why it happens that way is because the current which you are already seeing here is saturated current. And you may ask, how do I know whether the current is saturated current or the current somewhere in between? So I can easily understand that by looking at the electrons coming from the cathode. So all the electrons which are coming from the cathode at this moment are reaching the anode. So which means the current which is established in the circuit is saturation current. And that is the reason why as I increase the intensity, the saturation current also increases. Okay, now let's see what happens if I change the voltage of this battery. If I make it more positive, what is going to happen? So if I increase the voltage of this battery, you can see that the electrons are now moving faster. The now voltage is now 3.2 volts. I'll further increase it further and further, and I've made it 8 volts. So when I made it 8 volts, the electrons are moving very fast. But there is one very important thing which you should notice here, which is that the current has not changed. I'll show you again. Even when the voltage is close to 0, the current is 0.047, and even when the voltage is very high, plus 8 volts, the current is 0.047. Now, you may get a doubt, why is it happening that way when the electrons are moving at a faster rate? So one thing you'll have to notice here is that even though the electrons are moving at a faster rate at high voltage, the gap between one electron and the next electron is larger as well. So eventually, the number of electrons reaching this cathode, or sorry, anode, will remain the same.